Hey everybody, so today we are moving on to part 4 of our JavaDraw ArrayList stuff, and it's going to build off kind of like the same way I hope that we're kind of building a program over time. So we're going to use a lot of stuff in part 3 and part 4, and then we'll use stuff in part 4 and part 5. So in part 4 here, our goal is to delete rain and remove it from the screen. And I want to explain why this is an issue, why we might want to include it to begin with. So let me start out with, this is my work from the ArrayList from part 3. And so basically, it's all the stuff that's here, right? We're doing rainfall, we're adding rain, adding the random rain, all that stuff. The only thing that I've added on here that you won't have on yours is I put this little thing called a counter in here. I just made a text called counter, put it on the screen, it's this, and really all it's going to do is find the size of the array list and then position it in the bottom right. And then as we go through the loop, what I'm going to do is just update the text to still show counter and then the current size of the array list. And I hope that this gives an idea about why it might be an issue to not delete stuff. So let's take a quick run at this. Start here. Hopefully this is the right window for that. Yeah, here it is. It's hard. Maybe hopefully the audio won't be too bad for this. Yeah, so we have this running, and you can see that this counter is never increasing, or excuse me, it never stops increasing because, and remember, this is the size of the array list. And the reason that this counter is never decreasing is because even though our objects are off the screen, we need to manually delete them. Just because they disappear from view doesn't mean they're not there. So kind of it's like they're still moving, we just don't see them on the screen, and the array list is still keeping track of them. And so what that's going to do eventually is use up a lot of our memory. It's really just not a good programming practice to waste memory like this. So let's close this. We can illustrate this a little bit more to see how fast this is going to add up. Let's just do this one real fast. What I want to do is just, I'm going to do a loop. Instead of adding one rain every time, I'm going to add, let's say I'm going to add 20 of them. So we'll just do a quick little for loop here. I do want to make this video, I want to mind my time because I know it's going to take a while to get this. So in here, basically what I'm doing is every time I call add rain, it's going to run this loop 20 times and add 20 pieces of rain to the screen. So let's take a quick look at that. Okay, and so what you can see now is you can see the counters going crazy, right? And it's going to keep increasing. And you can see this on my computer, it might be slowing down a little bit because I don't have a lot of memory on this school computer, and my recording software is taking up some, and now this is starting to slow my computer down even more. So it's just generally not a good programming habit to slow down computers or slow down the coding if it's not needed. So let's stop this. So we can see this value is already up to 1,500, and it's going to start to slow the computer. So let's go back into here and figure out what we can do differently about this. I'm going to get rid of this for now. Basically all I want to do here is, and there's a few different ways I can implement this. For you guys, I had just added a separate method called public void delete rain. There's different ways you could do this, but this is the way I'm going to do it just for. And basically what I want to do is, so I have my rain falling on the screen, and I really just want to check to see, I want to keep checking to see where is the rain in the array list. And when its Y value gets to be close to, say, the bottom of the screen, I want to delete it. So I'm going to call my method in here, and then of course I have to write it. So let's go down into my method here. And okay, so there's easy and hard parts about doing this. Let me show you the easy way, and then some troubles that we're going to have doing the easy way. So the easy way is just to make a for loop. For oval O in my array list, I think it's called rain. Basically what I want to do, so I'm going to look through every oval inside of that rain array list, and then I want to check and basically see its Y value. And I'll say if the Y value for the individual rain is greater than, I'm going to say 780. Oh no, I've done this many times. It should be 580, right? Because the Y values range from 0 down to 600 for us. So if the Y value is bigger than 580, all I'm going to do is I'm going to go into the array list, and I'm going to remove O. Okay. And this will actually work. This is a good way of removing something from an array list. It's a fine way of removing it. We have an object, and basically Java, the array list is already set up, that it'll go find this value in there and delete it from the array list, and no problem with that. But let's see how this is going to work. So let's run this, and we'll see how this works, but there's also some problems with it. Well, mostly there's a little bit of problems. All right, so here we go, It's going to hit the bottom, and boom, it's going to freeze. Not my computer, surprisingly. It is actually just the way that we wrote this code. And we're going to go back into here, and we're going to find this error. So we see this concurrent modification exception. So concurrent modification, concurrent means like ongoing or going at the same time. Modification means to change, and then exception is like an error. So basically what it means is that we are changing something while we are using it. Like we're using two things, we're doing two things at the same time to our data, and that's causing some confusion, and that's going to cause the code to break. And if we look in here, if we search back through this, it's happening in the method delete rain. I'm not going to worry about this stuff too much. In main at delete rain at line number 51. So it's happening in here. Okay, so this requires a little bit of a deeper dive into how this for each loop is working. I'm not going to get too much into the details, but basically, there's some stuff going on in the background here that we cannot see. There's some complexity to how this works, and somebody else has set this up in a way where it's really designed to just loop through an array list very fast. But it kind of, one way to think about it is like when we run this loop, it's automatically going to decide like how many items are in the array list. So we say the size is say 200 or 50 or whatever it is when we get started, and it's expecting that size to not change. So when we go in here and we remove something from the array list, it's messing up our loop. And so that's where we get this concurrent modification exception. This is a really good thing to use. It's not something you shouldn't use, but if you use it for removing stuff, you'll run into this error just based on what's happening in the background that we can't see. So an easier way, a better way of doing this, not about easier, but better, is to just use a different loop. So I'll start with like int count is equal to 0, and then I'm going to say while count is less than my array list. So I'm going to just like old style, looping through an entire array list. Use this. And then what I want to do is, one thing I'm going to do for me personally, just to make my life a little bit easier here, I'm just going to say, I'm going to make a temporary oval. So I'm going to say oval temp is going to be equal to new oval. Instead of new oval, I'm going to say it's going to be equal to rain.get count. Let's see, down in here, we're going to increase count at the end, just kind of for our setup. So we're looping through the entire array list using some while loops, counts, all that stuff. We are getting a temporary oval. Each time we run through the loop, we're going to update temp to be equal to something, the object from the array list. And then what I can do in here is just say, well, if temp.y is greater than 580, then we can still use that remove thing. We'll do rain.remove, and I think we can just use temp here. We could also, I think you could use remove in either way. You could either put in the actual, the object that you want to delete, or you could also probably put count in here to get the actual index. But I'm going to do that like this for now. And so basically what we're doing, we're just not using a for each loop. It's same thing, same loop. But in this case, it's just a little bit less complex. So there's less stuff going on in the background. And every time we run to the end of this loop, it's going to check this statement. And so we're not really going to worry. If size changes as we're looping through, that's okay, because every loop we go through, we're going to check the size again and again. In the previous one, it was set up, in the for each loop, it was set up with a fixed size in mind, and that's going to, if we change that size, we're going to break the code. In here, we can think about every time we go through, we're checking this statement again. It just operates a little bit differently. And so let's take a run at this and see how that works. Here, let's close this down. Get back into here and see the counter's running. Okay, so now some interesting stuff is happening here. So the counter is not changing, which is good, because as objects get to the bottom of the screen, they are being deleted. However, you can see it's kind of like snowfall is piling up the bottom, which is kind of cool. But also maybe we actually really want to just get rid of these things. So all we need to do here, we have handled taking the item out of the array list, but we also need to delete the item itself. So I'm going to go into here, and right after I delete the item from the array list, I'm going to delete the item itself. And in JavaDraw, we can do that with temp, again, dot remove. And this just deletes the object itself. So let's just take another run at this. So it decides to load. Running. It's going to get down to the bottom. You can see the counter. It's kind of cool that the counter doesn't change because every time we lose one, we gain a new one, and it's kind of like staying in a constant balance of that. So this is why this is useful, and it's very useful. It's a good skill to have. It's also something you need to do on your quiz, or excuse me, on your project. You'll need to make sure that you remove items without triggering the concurrent modification error. It's useful to use the for each loop, but just not in every situation. This is one situation where you don't want to do that.